we're asked to solve the equation 2 sine theta cosine theta plus root 3 times sine theta equals 0 for angles between 0 and 360 degrees. And this one is particularly notable, or at least worth looking at, because if you're a little unwary, you could see that you have this, and you're like, oh wait, that looks like an identity. That looks a lot like, and in fact is exactly equal to, sine 2 theta. And you'd probably be a little proud of yourself having done that, but then you get the equation sine 2 theta plus root 3 times sine theta equals 0, and really that doesn't go anywhere for us. It certainly was a true identity. This equation is also equivalent to the equation we had before, but it doesn't actually move us forward. It's hard to deal with having sine of twice an angle and sine of an angle together. In fact, this was a case where a little bit of knowledge is a dangerous thing. It actually would be much better to leave it as it had originally been and instead pull out the sine theta and get to, from here, get to an equation that reads sine theta times 2 cos theta plus root 3 equals 0. Because now we can use the zero property and solve it relatively directly. The zero property says that if two numbers multiply to 0, then either the first or the second must be 0, or in some cases, I suppose, both. So we just say here, we say, well, either sine theta equals 0, or 2 cosine theta plus root 3 equals 0. Sine theta equals 0 where theta equals 0 or 180 degrees. And the other equation becomes 2 cosine, whoops, that's pretty terrible, becomes 2 cosine theta equals minus root 3, or cosine theta equals minus root 3 over 2, which is solved by theta equal to either 150 degrees or 210 degrees. How did we figure out the value for cosine theta equals minus root 3 over 2, giving us 150 or 210? Here we're going to try and find the reference angle by saying the cosine of the reference angle is, and we take the absolute value of our guy over here, so we get a first quadrant angle. So cosine of r is root 3 over 2, which gives us that the reference angle is 30 degrees. But cosine is negative, and that means that we're in either quadrant 2 or quadrant 3. If we're in quadrant 2, our angle looks something like this, and we know that this is 30 degrees, so the actual angle has to be 150, so together they become the straight line. Or we could be in the third quadrant, in which case our angle looks something like this, and our reference angle is here of 30 degrees, and clearly that's 210 degrees because we're past 180 by 30 degrees. Thus, our solution is theta is either 150 degrees or 210 degrees. One way to check our results is to graph it and to look for the axis crossing of this function, which would be at zeros, as we found before. So we pop it into Desmos, and we see that it crosses the horizontal axis at 0 and at 180, and also at 150 and 210, just like the solutions we had found. So we're pretty sure they're right.